Okay, class, this is chapter 4, number 28. On this problem, we have two masses that the 5 kilogram mass, is on an incline, and this 10 kilogram mass is hanging over the incline. And it tells me that this has an acceleration. So we can say the acceleration, the 10 kilogram mass is accelerating down, and the 5 kilogram mass is accelerating up the ramp. And it says that this is a smooth ramp, so that means that there's no friction on the ramp and there's no friction on the pulley. So what I'm doing here is I'm breaking this problem up into two parts so I can find two equations to solve for two unknowns. And my two unknowns are the acceleration and the tension. And if you are doing a problem like this, it's an important note to know that the tension is the same because it's the same rope. So both of these T's are the same. Since they're connected to the rope as well, both of the accelerations are the same. So since these are the same, I can isolate my 10 kilogram mass and come over here and set up an equation for that 10 kilogram mass. If I do that, I'm using the formula summation of my forces is equal to mass times acceleration. Since the 10 kilogram is all in the y direction, then I'm only going to sum the forces in the y direction, which gives me my tension going up. If we assign up as being positive, tension's positive. The weight is coming down, so the weight is negative. And if we're saying that down is negative, then this acceleration is also down, so I need to put a negative over here and say that's negative mass times acceleration. So now what I've done is I've written a equation with two unknowns. I have my tension and I have my acceleration. So here's one equation with two unknowns. I should be specific here and say that this mass is the 10 kilogram mass. So I'm going to put a little subnotation here of 1 to make sure that we don't mix it up with this mass, which I'm going to call this mass 2, and that's the 5 kilogram mass. So there's my first equation. So now down to the 5 kilogram mass. Now here I have three forces acting on this. I have my tension force. This force going up is the force of the ramp on the box, so that's called my normal force. And this is my weight pulling it down. And if we look at this diagram, we have two forces that are at an angle. And also my acceleration would be parallel to the ramp. So acceleration would also be at an angle here. So I'm going to do a trick of rotating this whole diagram down the 40 degrees. And what that does is that puts my tension horizontal. I still have a normal force going up. Let's do that in black. So I still have the normal force, but that you'll see is not going to be important here. So I have tension going to the left, I have acceleration going to the left, and down here I have my weight, but now my weight's going to be at the angle. I shifted this down, so that shifts the weight vector over 40 degrees. So I set this up, and here's my second equation. So since I'm looking for T and A, then I can sum my forces in the x direction, and that gives me an equation with T, and it gives me an equation with A. All these other things are known. I know what my mass is, I know what gravity is, and here's my mass again. So all of these are known, so I have an equation with two unknowns. And again, note that since acceleration is left, I'm saying acceleration or left is negative, I have to put that negative here. So this takes a little bit of algebra skills to be able to solve a system of two equations. What I would do is I would add these two equations together and the t would cancel out, leaving an equation with just acceleration. Then you could solve for acceleration, substitute that value back here, and solve for t. So this is complicated algebra, but should be within your skills. We can go over the answer in class and make sure that you have that ability to solve the system of equations. Okay, so we'll go further into detail in class.